Hello. How is artificial intelligence structured? How does it work? One of the reasons for the mystification of artificial intelligence today is that almost no one knows how it is structured. Well, there is a certain chat where you are invited to talk to artificial intelligence. You ask someone invisible about something, and suddenly IT responds to you, demonstrating intelligence and erudition clearly surpassing yours. This is somewhat alarming. Or, you describe your nightly visions in words, and it draws them for you in pictures, vividly and convincingly. Of course, as long as these visions adhere to the ethics of communication between strangers. It seems like there is someone living and intelligent sitting there. But who is really talking to us? This video will probably require some effort to understand. But without understanding what the monster that scares us looks like and how it is structured, we cannot overcome our fears. When we ask a question in a chat with artificial intelligence, a program running on a, let's say, powerful but quite ordinary computer responds to us. We are talking to a software robot, or bot, as programmers who save letters say. I prefer to call this entity a robot because it is incomparably more complex than the dull bots of tech support and social networks. Robots, which are today called artificial intelligence, are neural networks. Remember, we talked about billions of neurons forming temporary and permanent connections in our brain. Well, here it's about the same, only neurons are logical elements of program code. Connections between neurons are also established programmatically. These connections, in turn, have parameters. The state of neurons, connections between them, and parameters change dynamically, that is, constantly. The entire neural network is multi-layered. The logic of changing states, connections, and parameters is diverse and very complex. I won't burden you with technical details any further, although I myself have looked through a couple of books on this subject. We are not going to build our own neural network, so we only need the technique for general concepts. I will only add that the system has become complex, and we have stopped understanding exactly how it obtains results. Although we wrote all the logic of its operation, the neurons, connections between them, and the parameters of the connections live, so to speak, their own life. How complex is the modern neural network of artificial intelligence? The complexity of a neural network is usually reduced to the number of its parameters, that is, the properties of the connections between the neurons. According to experts, this number determines, so to speak, the scale of the system. No less important is the logic embedded in the system by programmers, but here, everyone talks at the level of principles and concepts, because it is precisely the specific logic that determines how the large-scale capabilities are used. It is clear that the complete specification of the logic is an object of intellectual property and is kept secret from competitors. And the competition, by the way, is fierce. There are neural networks of very different complexity, and we do not have access to each of them. There are versions of neural networks available for free access, meaning any qualified engineer can download the source code and install such a neural network on a quite accessible, powerful computer available in stores. There have even been ready-made installations. Take it, set it up, and use it. Freely accessible systems are relatively small in scale. The most advanced of the freely available systems, GPT-2, has 1.5 billion parameters. However, the version of ChatGPT 3.5 that we are familiar with has 175 billion parameters, which is 100 times more scalable. This leap still pales in comparison to the latest achievements. No one reports reliably how many parameters GPT-4 has, but its direct competitor, Google's Palm, has 540 billion parameters. That is 500 billion. However, Google also has a system with more than 1 trillion parameters. This is impressive. To somewhat cool the enthusiasm or fears, let's compare this with our brain. The human brain is estimated to have about 86 billion neurons. It is believed that 16 billion of them are responsible for intelligence. Incidentally, this is debatable, as many more neurons may be involved in intellectual activities. But let's assume it's true. Each neuron uses from 1,000 to 10,000 connections, which can be correlated with the parameters of a robot. This means that the number of parameters in our brain ranges from 16 to 160 trillion. Compare this with the mere 1 trillion of the largest neural networks. The growth in the scale of neural networks is restrained, in part, because the larger the system, the more costly it is to train. There is almost a direct analogy with smart and not so smart people. Fools can be easily trained for simple work. Smart people need to be taught for a long time, and they must be taught by smart people to unlock their potential. Very large neural systems, by the standards of neural networks, are difficult to train to work at full capacity. It may happen that a smart system will do the work of an idiot because it is undertrained. Before we delve into how neural networks learn, let's understand how they work. Firstly, we need to remember that we are not just talking about neural networks, but about intelligent robots that understand our questions and answer them competently and in the correct language. The key here is the understanding of the question and the formulation of the answer based on known information, vocabulary, and grammar. For analogy, imagine a person who has memorized the largest encyclopedia and, in addition, read a lot of fiction. This results in a knowledgeable and well-read person, but not necessarily a smart one. I personally know at least one such fairly famous person. If you ask such a person a question, they will quote suitable encyclopedia articles and might even add a couple of quotes from literary classics, using their brain's purely computer-like function of searching and compiling information. To some, this might seem a sign of intelligence, but we usually don't award a doctorate for a dissertation compiled from other people's work. Being informed and possessing speech is not the same as being smart. Modern neural networks operate in much the same way as the aforementioned encyclopedist. Let's start with the fact that all these neural networks belong to the LLM group, which stands for Large Language Model. Essentially, LLM neural networks learn to use words without understanding their meaning. They respond to a set of words in a certain sequence with another set of words in a specific sequence. In doing so, the set of words and their sequence in the response are considered by them to be most likely correct. Each word for them is a number in their computer system. If we reject an answer as unsuitable, the neural network offers us the next most probable answer. And if we accept this second answer, the neural network makes adjustments to its settings. That is, it learns on the go. Of course, I am simplifying. Of course, everything is somewhat more complicated, but the essence remains. An LLM neural network is a robot for selecting words. It selects one set of words in response to another set of words. This robot can match the environment of words in different contexts and generate new probable contexts with these words, but it does not go beyond the formal logic embedded in it by programmers and beyond the data obtained during training. This is the best that robots have been taught to do in the intellectual sphere. It sounds quite demeaning for something called some kind of intelligence, but the result is impressive, as we have become afraid of the emergence of a super-intelligence. So how do neural networks learn? The study of neural network training is the subject of scientific works and applied reports. There is a whole scientific discipline called deep learning, and even the simplest presentation of its basics would require several academic lectures. I think we don't need that here, and I'm simplifying again to the extreme. Roughly speaking, there are 3 stages of training. In the first stage, a huge amount of text is loaded into the neural network. In the most general case, this is a large part of internet pages in various encyclopedias. The set may include special books like textbooks on anything, for example, law, history, medicine, business, marketing, anything that is described in books. Fiction can also be included, but the robot won't distinguish fiction from reality, so it may take Gulliver's Travels for pure truth without fiction. Having selected all the words from this mass, the robot begins to self-train. First, it takes a short phrase, hides one word in it, and tries to match it, changing its parameters. After each substitution, it compares the found word with the hidden original and continues to adjust its parameters until it guesses correctly. Then the process is repeated with a longer phrase and 2 words. Then with a paragraph and several words. Then with a page and many words and whole phrases. Gradually, the robot learns to guess words and phrases in each of the books and internet pages loaded into it. Since logic tells the robot how to respond to the input text, it constructs a response phrase based on its experience and vocabulary. Remember, this is still essentially a meaningless reaction of one set of words to another such set. In the second stage, people teach the neural network. They teach it to communicate. They ask questions and correct the received answers according to the principle, "This is how it should have been." And the robot remembers this and gradually learns to answer as people, its trainers, do. The third stage of the robot's self-learning never ends. We, the regular users, conduct it. We ask questions, the robot answers, we evaluate the response. The robot takes this evaluation into account and adjusts something in its brains, or rather its parameters. The absence of a reaction to the answer is taken as a positive assessment, roughly like that. So where is the intelligence in this? In my description, the neural network certainly doesn't appear to be intelligent. I might be told that the devil is in the details, that high complexity itself could become a source of self-awareness, emotions, and more. In my opinion, this is a myth. Besides, even formally, the complexity is still an order of magnitude lower than the level of the human brain. Not to mention that a human neuron is significantly more complex than a programmatic neuron, and the synapses of the nervous system are incomparably more complex than programmatic connections with parameters. The aforementioned appeal by wealthy intellectuals demanding to stop the development of artificial intelligence is more related not to the fear of the emergence of superintelligence, but to establishing responsibility for the advice given by neural networks. A robot lacks empathy, feelings, and responsibility. It can, but should not, give people advice on issues affecting spheres of existence, morality, relationships. That is why it is necessary to establish and firmly fix that. For example, medical advice from a neural network cannot be a guide to action. This, in my opinion, applies to the legal sphere and much more. By the way, a robot cannot distinguish truth from falsehood, and the famous Dr. House always assumed that everybody lies, well, or omits details. Artificial intelligence is a new powerful tool, and we must learn to use it for the benefit of people. Considering our historical experience of turning everything into a weapon, this will not be easy. To begin with, robots will enter the intellectual spheres of activity and force people to either rethink their role or give way. I see more risks here than in the potential superintelligence. But that's a topic for another video.